Okay, here we're just going to review some of the topics related to the fluid in motion. First of all, we're just going to review today total headlines, which is called THL, and also hydraulic grade line, which is called HGL. And then later we're just gonna review these kind of like the THL and HGL in the reservoir and pipeline flow. Then later head losses in pipeline and minor head losses. Okay, so if we just consider that we have like a pipeline, we have a pipeline like this one, and between any 2 points, for example, in this case, like the point A and point B, we have a standing pipe. In the standing pipe, we can have like a piezometric pressure. Piezometric pressure is like shown by here, PA over rho G, for example. And it's the same for point B, PB over rho G. So we have like another like the velocity, specific velocity here. For example, it shows like the velocity head in here and the velocity head at point A and B. And if you have like a reference line or datum horizontal reference line, we can just write Bernoulli's equation between these 2 points, as you know. So if you're just going to write the Bernoulli's equation, on the left-hand side, we have 3 terms, as you know. The elevation head, ZA, is the difference between that points above the reference line, ZA, plus the velocity head, alpha A. Alpha is like a coefficient, velocity coefficient. We could be, if we don't have any data, we can assume it as like the alpha is equal to 1. And alpha A, VA squared over 2G. So it is like a velocity head, the second term. And also the pressure head is like the PA is the pressure, is the depth or the height of the water column in the standing pipe, that we can show that as like a PA over rho G. It's for the first hand side. For the second point, point B, we have the same 3 terms, ZB, alpha B, VB squared over 2G plus PB over rho G. And one thing's difference that we're just going to have on the right-hand side for point B, once the energy moves from like the point A to point B, it might just lose energy. Losing the energy is denoted, or is just shown by the energy head losses term. So in here later on, we're just going to learn how we can calculate energy head losses. So what for now, just bear in mind the 3 terms of the Bernoulli's or the energy equation. Once you're just going to go to the second move, like the point moves to the second point, we're just going to have, or we might experience energy head losses. So we have to just put energy head losses on the right-hand side. So let's look at like the levels that we have. The total sum of the 3 terms of the elevation, pressure, and velocity is called total headline, or THL. Okay, so either point A or point B. So at the top of that, so we have to just ignore the energy head losses. We don't have energy head losses. This is something that we lose. Okay, so the energy or the total headline is THL, is like the and the line connecting between these 2 can be shown here like by using this kind of like a dashed line. And if it's just going to reduce or subtract the velocity head from the total headline, THL, we can get another term that we can call like the hydraulic grade line, or hydraulic grade line denoted by HGL. So the hydraulic grade line is something that is shown by the piezometer. So the hydraulic grade line is the sum of the elevation head and the pressure head together. And another like the definition that you need to just bear in mind is the gradient of this between these 2 points, gradient of the hydraulic grade line, for example, gradient or the slope of this line, that normally in hydraulics is shown as the 1 in 100 meters, for example, or like whatever in 100 meters. It could be like the half a meter, meters in 100 meters length, the amount of the drop in a specific length of distance of length of the pipe, horizontal pipes, is denoted like the, for example, whatever drop in a specific like 100 meters of the length. Anyway, so that sort of like the gradient or a slope of the HGL is called hydraulic gradients. So the hydraulic gradients, once we have, means that whatever like the drop that we have in the hydraulic grade lines, in a specific length that normally is just in like 100 meters. So this is like the definition of the total head line and the hydraulic grade line.